so for number one, we're reducing here. What can both 45 and 75 be divided by? 5. So 45 divided by 5 is 9. 75 divided by 5 is 15. They can still both be divided by 3. So we get 3/5. 42 over 60, both can be divided by 6. Good. 42 divided by 6 is 7, and 60 divided by 6 is 10. Here, renaming. What do we have to multiply the 3 by to turn it into a 21? 7. So it's 2 times 7 makes 14. So 14 over 21. 4 times what to make 20? 5. So 3 times 5 is 15. Any questions so far? Okay. Converting into mixed numbers. How many times does 3 go into 25? 8 with how many left over? 1/3 left over. Good. 4 goes into 47 how many times? 11 with how much left over? 3/4. Good. Remember, we can think of that like a division and remainder. It's 47 divided by 4. 4 goes into 4 once. There's nothing left over. We just have the 7. 4 goes into 7 once. There's 3 left over, so there's 3/4. So 11 3/4. So down here, going from a mixed number back into an improper fraction, 3 2/5 is going to become how many fifths? 17. Good. 3 times 5 is 15, plus the 2 makes 17. And of course, the denominator does not change when we're converting between mixed numbers and improper fractions. So this is going to stay eighths. How many eighths is it going to be? 43. Good. 5 times 8 is 40, plus 3 is 43. Any questions? Okay. So we had worked on that reducing and renaming last week. I want to show you something. We talked about factoring a couple of weeks ago. And why did we talk about that? Actually, we talked about it last week. Why did we talk about that right before we did fractions? Well, if we have something like 12/20, to reduce it, what we're looking at is factors. 12, if we factor it, becomes 2 times 2 times 3. 20, if we factor it, becomes 2 times 2 times 5. When we go to rename a fraction, we have two options. We can either cancel like factors, or we can, I don't want to say add because we're really multiplying, we can put in a new common factor. So what do I mean by that? Well, here we've got 223, 225. I can cancel that 2 in both of them because that's a common factor. That would leave me with 2 times 3 on top, which would be 6, and 2 times 5 on bottom, which would be 10. So when I'm reducing these fractions, dividing top and bottom by the same number, what I'm really doing is canceling common factors. Now we know we wouldn't be done there because we got another 2 we could cancel. We cancel out that 2, and now we have no more common factors. We're left with 3/5. I might have, let's see here. (60/90). And if I factor these, come on. 60 factors into 2 times 2 times 3 times 5. 90 factors into 2 times 3 times 3 times 5. Now, if you don't remember how to factor, remember that's when we do the factor tree. 60 could be 10 times 6, or 2 times 30, or 4 times 15, however you want to start it. 10 is 2 times 5. 6 is 2 times 3. Does that look familiar? Anybody have questions on coming up with those factors? Or we're all good on it? Okay. So that's where we got the 2 times 2 times 3 times 5 for the 60. Now that we have that factored, we can cancel out. There's a 2 in both of them, and there's a 3 in both of them. What that leaves me with on top is 2 times, oops, and what else do we have in common? There's a 5 I can get rid of, right? So that leaves me with on top is just the 2, on bottom just the 3. So I could have, let's see here. Careful. Let's do 28 over 30. Factor 28 for me. Tell me what the factors come out to be. So 28 factors to be what? 2 times 2 times 7. 30? What's that? 2 times 3 times 5. Good. What can we cancel there? Just the 2. Nothing else in common. So on top I have 2 times 7 is 14. On bottom I have 3 times 5 is 15. When I went to rename a fraction, let's say we had 3/5 and I wanted to turn it into tenths, what we were basically doing was adding a factor. We had to multiply the 5 times 2 to make 10, multiply the 3 by 2 to make 6. So all we've done is put an additional factor into each of them. So as long as we're either putting in or taking out common factors from the numerator and denominator, we will not change the value of that fraction. So the reason the question comes out, why am I going over this? Well, we talked about things like this. I'll make it x to the 8th over x to the 3rd. And how we dealt with those powers. X to the 8th is 8x's multiplied together. X to the 3rd is 3x's multiplied together. And we can go back and forth between a division problem and a fraction. So if we keep this division problem here as a fraction, I can cancel out common factors, just like I could with fractions. Now, if everything cancels out on either the top or bottom, that means it's a 1, right? Just like if I had 3 over 9, I divide both by 3, I'm left with 1 over 3rd. I'm not left with a blank over 3, right? So what's on bottom here is 1. On top is x to the 5th, because there's 5 of those x's still left. So it's x to the 5th over 1, or just x to the 5th. If I had, now what did we say our shortcut was? Remember? We took, 8 minus 3 to get 5. We subtracted the powers when we were dividing. We might have y to the 4th over y to the 6th. So that's 4 y's multiplied together on top, 6 y's multiplied together on bottom, and again, we can cancel. 1, 2, 3, 4 of them cancel. So everything canceled on top, which means what's on top? 1. And on bottom, we just have 2 y's, so that's y times y is y squared. So it's 1 over y squared. Now, if we were to just subtract our powers, 4 minus 6 would have been negative 2. And we have mentioned this briefly before, that a negative power is a reciprocal. Y to the negative 2 is really 1 over y to the 2nd. But for right now, when we see something like that, let's say I have z to the 5th divided by z to the 12th, we can just do 5 minus 12 is negative 7. It's okay to write that as z to the negative 7. So once again, why am I going through all this? Well, because we're going to run into fractions like this. Now, we've done division problems like this before, and this one is going to work out just like a division problem. Remember, we divided the numbers first, the counts. What's 12 divided by 4? 3. Good. X to the 8th divided by x to the 5th. X to the 3rd, 8 minus 5 is 3. Now we treat this as y to the 1, so y to the 3rd divided by y to the 1 is y squared, or y to the 2nd. But what if it doesn't divide out nice and neatly like that? What if it looks more like this? Now here, we would have been asked to divide. Here, what I'm going to ask you to do is just reduce. So we're simply reducing a fraction. Well, just like we were doing up above, we can reduce this by factoring. So I'm going to factor 12x to the 8th, y to the 3rd. To factor it, I'm going to do the number first. I'm going to ignore the variables. 12 would be, what, 4 times 3, 3 is prime. 4 is 2 times 2. So I have 2 times 2 times 3. That's the 12. Well, x to the 8th is just 8 x's multiplied together. Y to the 3rd is just 3 y's multiplied together. So I factored my 12. 12x to the 8th, y to the 3rd. 16, if I factor it, if I do the same thing, 16 is 2 times 2 times 2 times 2. X to the 5th. It's 5 x's. Y to the 5th is 5 y's. So if I go to reduce here, I cancel out a 2 and another 2. How about for x's? 1, 2, 3, 4, 5 will cancel out. For my y's, 1, 2, 3 cancels out. So what's left on top here? 3 x to the 3rd. On bottom, well, 2 times 2 is 4 y squared. Now, looking at this, we should see a lot of similarities to some of the examples we've done earlier today. 12 over 16, first of all. Both of those can be divided by what? 4. There we go. 12 divided by 4 is 3. 16 divided by 4 is 4. That gave us the number portion, the 3 over 4. Earlier, when we did x to the 8th divided by x to the 5th, how did we get the result? We got x to the 3rd. We subtracted the powers, 8 minus 5, to get 3. We got x to the 3rd. Well, if we look at the y, we've got a 3 and 5. 5 minus 3 is 2. But why did I put it on bottom here instead of on top? Why did the y squared end up on bottom? Yeah, the bigger power was on bottom. So when I canceled out, the leftover pieces were on the bottom of the fraction. It's still, however, 5 minus 3 is 2. Does that make any sense? So when I am looking at a problem like this, I can separate out the numbers. 15 over 35. Perfect. Yeah, both of those can be divided by 5, which would give us what? Careful. There you go. 15 divided by 5 is 3. 35 divided by 5 is 7. So that's going to give us 3 over 7. For the variables, I can do each variable at once. I've got x to the 9th and x to the 12th. Now, first thing I need to figure out is if the x is going to go in the numerator or denominator in my answer. It's going to go on top or bottom. How do I know? Well, where's the bigger power here in the problem? On the numerator or denominator? It's on the bottom. It's in the denominator, x to the 12th. That means my x is going to end up in bottom in my answer. To find its power, what's 12 minus 9? 3. Good. Where's the y going to end up, top or bottom? It goes on top because the bigger power is on top. And it's going to end up with a power of 2. Good. 5 minus 3 makes 2. So I can divide out the numbers first, reduce the numbers, and then I can deal with each variable one at a time. I do need to caution you just a little bit. So to reduce this, I'm going to start out with the numbers, 24 over 16. Both of those can be divided by what? 8, I heard someone say. 24 divided by 8 is 3. 16 divided by 8 is 2. Normally, if we saw 3 over 2, we'd change it to 1.5, wouldn't we? Here, though, we cannot. Why not? Well, it's going to be 3 over 2 here, but that's not all that's going to be there. There's going to be variables back here, isn't it? So let's go through with the variables, and then we'll come back to why that cannot be made into 1.5. So what are we going to do for A? Top or bottom? Top, and what power? 2, good. The larger power, 13, was on top, and we subtracted. 13 minus 11 made 2. B, top or bottom? Bottom. Power? 3. Very good. The larger power was the 12 on bottom. 12 minus 9 gave us 3. C. Cancels out. They have the same power. 3 minus 3 is going to be 0. So C to the 0 is just 1. So we don't have to put it in our answer. So now back to this. Why can't I do the 3 over 2 and make it 1.5? Well, because it's not just 3 over 2. It's 3a squared over 2b cubed. We don't know what a and b are. We know that they stand for missing numbers, but we don't know what numbers they stand for. A could be a really small number and b could be a really large number. This might not be an improper fraction. So because we don't know the value of those variables, this is not an improper fraction. At least we can't prove that it's an improper fraction. It may end up being that way depending on the values of a and b. But we cannot assume that it's improper, and we can't split it up into a mixed number until we know for sure. So you would have to leave it like this. The reason I say that is every semester on the test for this section, I do have somebody that splits that into 1 and 1a squared over 2b to the third. You can't do that. It is not an improper fraction. I'm going to have you guys try one in your notes, see how you do. Give that one a shot, see what you come up with. Okay, so we're going to take the numbers 39 and 52. Can anybody see what both of those are divisible by? 13, very good. So 39 divided by 13 is 3, and 52 divided by 13 is 4. So up here on our answer, the number is 3 over 4. How about A, top or bottom? Bottom, power of 2, good. The larger power for A was on bottom, the 9, and 9 minus 7 is 2. B, top or bottom? Bottom, power of 6. There we go. The larger power for B was the 15, that's on bottom. 15 minus 9 is 6. And how about C, top or bottom? Bottom, and power? Just C, or we could do C to the 1. 4 minus 3 is 1. So C to the 1 or just C, and the larger power was on bottom. So there it is, 3 over 4a squared b to the 6c. How many of you had that? Anybody have major questions on how we got that? We're not sure how we got to that. Okay, so I want you to try another one. Try that one quick and see how you do. So for the numbers, 12 over 36 reduces to 1 over 3. Now in our answer, I'm going to put the 1 on top, but we might not need it there. And I'll show you why in a little bit. How about for the x? Top or bottom? Bottom, power of 1, or just x. Y goes away, divides out. Y to the 8th divided by y to the 8th is 1, so it's gone. Z on the bottom and a power of 3. So here we did need that 1 left up there. But there are times when we don't need it up there. We might have like 9x to the 8th, y to the 13th over 45, x to the 10th, y to the 10th. So we're going to reduce the 9 over 45. What can both of those be divided by? 9. Very good. 9 divided by 9 is 1. 45 divided by 9 is 5. So for the number portion, we've got 1 over 5. Where does the x go? Top or bottom? Bottom. Power of 2. Good. The 10 is the bigger power. 10 minus 8 is 2. Y goes on top with a power of 3. Good. 13 is the bigger power. 13 minus 10 is 3. Here, I don't need the 1 anymore. Just like if I just have an x, I don't need 1x. So the best way to write this would be y to the third over 5x squared. Now, it would not be wrong. It would not be incorrect to have the 1 there. It's just, again, that math grammar thing. It's more proper to not have it there. If in my math lab you put that 1 in there and it marks it wrong, let me know and I will change that grade for you. My math lab can be just a little bit picky about that at times. So we can reduce those fractions even with the variables in them because it is just the factoring. Now we haven't done any with factoring for a few examples here. But remember, the reason why we are able to do that is simply because we are canceling factors. You know, the 20 is 2 times 2 times 5, and then x to the third, y to the fifth. And the 12 is 2 times 2 times 3, x to the fourth, y squared. And really what we're doing when we do that process, we're canceling out factors. The 2's cancel out. Well, that's what we did when we pull out 20 and 12. Both of those can be divided by 4. Give us 5 over 3. We're canceling out the 2's is all we've done there. And then when we subtract the powers for the x's, 1, 2, 3, we've canceled out those x's. And the same for the y's, we cancel out or we subtract the powers, we're canceling those out. So on top, we have 5y to the third over 3x. What did I do wrong there? Anybody see what I just did wrong? I made it into a mixed number, didn't I? From this point, I am done. I cannot do any more with that. Even though it's 5 over 3, it's not just 5 over 3. It's 5y to the third over 3x. I have no idea whether this is an improper fraction or not. So I cannot split it up into a mixed number. I must leave it like this. So again, be very careful of that. So some examples we'll run into. My math lab can be a little bit corny about writing fractions and reducing them. It might give you something like your gross pay is, let's go $48,000. And you pay $16,000 in taxes. What fraction of your gross pay is your tax? Or is the amount of tax you pay, however you want to word it. So we're looking at this. We have two numbers, 48,000 and 16,000. We're saying what fraction. So obviously we're going to be putting them in a fraction. To figure out which one goes in the numerator, which one goes in the denominator, we have to look at the wording. It says, what fraction of your gross pay? Now when we talk about percents, we're going to talk about this a lot. Which says what fraction of your gross pay, we can read that as out of your gross pay, which is implying the gross pay is what this is all based on. So that would be what goes on bottom, the gross pay, which is how much? The 48,000. So what fraction is your tax out of your gross pay? So your tax is going to go on top, which is, of course, 16,000. Now, when I go to reduce fractions with large numbers like this, I had mentioned earlier the first thing I always look for is dividing by tens because it's zeros. Well, here it's not just a single zero, it's 3 zeros, which means both of these can be divided by what? 1,000. Yes. So if I divide 16,000 by 1,000, I get 16. 48,000 divided by 1,000 is 48. What can they still be divided by? 8. Well, that'll work. 16 divided by 8 is 2. 48 divided by 8, 6. And we can still divide by 2. 2 divided by 2, 1. 6 divided by 2 is 3. So it's 1/3. So for this person here, 1/3 of their gross pay is taxes. That's an important thing to be able to pick out. It's something called the base of a problem. The base of a problem is something the calculations are all based off of. The amount of tax you pay is based off of your gross pay or your earnings. So you know that's what everything's based off of. That has to go in the bottom of your fractions or your ratios. On a day when 6,500 parts are produced, $130 are found to be defective. What fraction are defective? Okay, now here I didn't say anything about being based off of anything. You know, I didn't say what fraction of something is defective. Now I didn't say it, but that doesn't mean it isn't implied. Say what fraction are defective. What I'm really asking is what fraction of what? I'm asking what fraction of all parts produced. Yes, what fraction of the parts are defective. Which implies that when I set up my fraction, what goes on bottom is total parts. So that means on top would be the defectives. Because we're asking what fraction are the defectives out of the total parts produced. So what number goes here for the total parts? 6,500. What number goes on top for the defectives? 130. What can both of those be divided by? What's that? 13 works. Good. 130 divided by 13 is 10. 6,500 divided by 13 is 500. Both of those can now still be divided by 10. So 10 divided by 10 is 1. 500 divided by 10 is 50. So what that's saying is 1 out of 50 parts produced was defective. Now sometimes we might have more than two different things that we're looking at, or more than one special category. For example, let's say that we are looking at used car sales for the month. We're W and we're, get out of there. H and we're. Used car sales for the month were, say, 24 Fords, 18 Chevy, 20 Dodge, and 8 other. What fraction of sales were Chevy? So obviously we're focusing on Chevy, but what is it going to be based off of? What fraction of sales? Now the word that's implied there would be total sales. Very good. So we have Chevy, which is 18. What number is going to go on bottom? All of them added up, yes. 24 plus 18 is 42, plus 20 is 62, plus 8 is 70. Then what? $18 and $70 can both be divided by, they're both even, so they can both be divided by 2. 18 divided by 2 is 9. 70 divided by 2 is 35. And that's as far as we can take it. So 9/35 of all car sales for that month were Chevy. Does that make sense? Okay, let's see here. Let's say in the class, 8 students earned A's, 12 earned B's, $19 earned C's, and $9 were D or worse. What fraction of the class earned an A or B? In your notes, try to figure that one out for me. So it's obviously out of the total class, the total students. And that would be found by doing the 8 plus 12 plus 19 plus 9, which gave us what? 48. And on top, perfect. Just the A's and B's, which is the 8 plus 12, which, yes, that is 20. What can both of those be divided by? 4. 20 divided by 4 is 5. 48 divided by 4? 12. So 5/12 of the class were A's or B's. Any questions? Okay, it's about time for our break, so let's go ahead and take our break. We'll do 10 minutes. We'll come back at about 9:29, and we'll start with our second half.